Did you know that if you took all the empty space out of every atom and every person on Earth, you could fit the entire human race into a volume the size of a sugar cube? It's a staggering thought, isn't it? That's how tiny atoms are, and yet they make up everything around us. It's mind-boggling. These minuscule particles are the foundation of all matter, the very essence of our existence. Atoms are the fundamental building blocks of matter, like tiny Legos that make up everything we see, touch, and even breathe. They are in the air, in the water, in the food we eat, and even in our own bodies. Imagine a world made entirely of these tiny particles, constantly moving and interacting with each other. This dynamic dance of atoms is what gives rise to the diverse materials and substances we encounter every day. That's the fascinating world of atoms. They are the invisible architects of our universe, tirelessly working behind the scenes to create the reality we live in. Understanding atoms helps us unlock the mysteries of the universe and appreciate the complexity of the world around us. So, what exactly is an atom? It's a question that has fascinated scientists for centuries. In simple terms, an atom is the smallest unit of an element that still retains the chemical properties of that element. Imagine it as the fundamental building block of matter. Think of it as the smallest piece of gold you can have that's still considered gold. If you keep breaking it down, you eventually reach a point where it's no longer gold. Break it down further, and it's not gold anymore. It becomes a collection of protons, neutrons, and electrons. Atoms are incredibly small, much smaller than anything we can see with our naked eye, even with the most powerful microscopes. To give you an idea, a single strand of human hair is about 100,000 atoms thick. But despite their size, they are incredibly important because they determine the properties of everything around us. From the air we breathe to the materials we use, atoms are the foundation of all matter. Now let's dive into the fascinating world inside an atom. At the center of every atom is a tiny nucleus, like a sun in a miniature solar system. The nucleus is made up of two types of particles, protons and neutrons. Whizzing around the nucleus are even tinier particles called electrons. These electrons are constantly in motion, orbiting the nucleus at incredibly high speeds, much like planets orbiting a star. This constant motion creates a kind of energy shield around the atom. Section 4. The role of each particle. Each of these subatomic particles, protons, neutrons, and electrons, plays a crucial role in the atom. Protons carry a positive electrical charge, while electrons carry a negative charge. Neutrons, on the other hand, have no charge. They are neutral. The number of protons in an atom determines what element it is. For example, all carbon atoms have 6 protons, while all oxygen atoms have 8. This is what gives each element its unique identity. It's like their atomic fingerprint. Section 5. The atomic signature and the periodic table. This unique number of protons in an atom is called its atomic number. The atomic number is fundamental because it defines the identity of an element. For instance, hydrogen has 1 proton, so its atomic number is 1, while carbon has 6 protons, giving it an atomic number of 6. This number is crucial in distinguishing one element from another. Scientists have organized all the known elements in a chart called the periodic table, arranged by their atomic number. This arrangement not only helps in identifying elements but also reveals patterns in their properties. The periodic table is a powerful tool that has evolved over time, with contributions from many scientists including Dmitry Mendeleev, who is often credited with its creation. It's like a giant map of all the building blocks of our universe. Each element has its own unique place on this map, and the table is color-coded to show different element groups, such as metals, nonmetals, and metalloids. This visual representation makes it easier to understand the relationships between elements. The periodic table is an incredibly useful tool for scientists because it allows them to predict how different elements will behave and interact with each other. By understanding the position of an element on the table, scientists can infer its chemical properties and reactivity. This predictive power is essential in fields like chemistry, physics, and even biology. It's like a cheat sheet for understanding the universe. Whether you're a student learning about elements for the first time or a seasoned researcher, the periodic table provides a wealth of information at a glance. It's a testament to the power of scientific organization and discovery. From the air we breathe to the food we eat, everything is made up of atoms. These tiny particles are the fundamental building blocks of all matter. and their interactions determine the properties of the substances we encounter every day. Understanding atoms and their behavior is crucial for advancements in science and technology. Understanding atoms is key to unlocking the mysteries of the universe, and it all starts with appreciating the incredible world inside these tiny, fundamental building blocks of matter. By studying atoms and their interactions, we can gain insights into everything from the simplest chemical reactions to the most complex biological processes, paving the way for new discoveries and innovations.